Hello, college algebra. We're back talking today a little bit. I can't remember what section we're on here. I think we're 1.7, 1.8, because I can look it up. But anyways, we're talking about absolute values, okay, for both their equations and their inequalities. And so, first of all, let's just make sure we understand the notation and what we're talking about here. When we say the absolute value of x equals 3, what are the possibilities for x? Well, if it's 3, the absolute value of 3 is 3. If it's negative 3, its absolute value is also 3. And so we show those two, and we'll say here's 3, there's negative 3. Obviously 0 is right in between there. So we'll put 0 there, and we'll change that over. And we'll say there, that's a solution, and there's a solution. Now what do they have in common? They're the same distance from 0. One's 3 to the right, one's 3 to the left. That's really what it is. Now what about when we say here, x minus 4 could be 2. Can you think with me on what this x could be? Well, what could it be? Well, this stuff in here could be 2, and that means that x minus 4 equals 2. Excuse me. So x minus 4 is 2 is one of the possibilities. Now the other possibility would be that x minus 4 could be, and if x minus 4 is 2, x equals 6. Okay? So, because 6 minus 4 is 2. So I could go up here, and that's 3. And then this is 4, 5, 6. Okay, so there's 6. The other possibility is what? It's that this inside of here was negative 2, and then its absolute value became positive 2. So the x minus 4 was negative 2, and we add 4 to both sides, and that x could be positive 2. And so we could say, oh, you mean 1, 2, that could be another one. So there could be an answer at 6, and there could be an answer at 2. And what do they have in common? Well, if you think about what's halfway in between 6 and 2, 6 plus 2 is 8, 8 divided by 2 is 4. What's halfway in between is 4. And what we know there is, from 4 to 6, that's 2 to the right, that's 2 to the left. The distance between our solution and 4 is 2. So that's kind of the idea that we're going to get at. Now, we'll do this analytically, so we'll do it kind of without thinking about that. We'll kind of get a process that'll work. But that's why it works, because an absolute value is just a distance. Okay? A distance from the origin, or distance from something. So this is a distance from something. That was a distance from 0. We can also say we have inequalities. We could write an inequality for the statement. Here's the numbers x, that are more than 2 units from 5. So down here I'm going to put 5, and I'm going to go 2 units to the right. Then I'm going to go 2 units to the left. I want more. I want the numbers that are more than 2 units. So I want these out here, and I want those right there. Okay? So that's really what we're talking about when we talk about these x's. Here's my x's here, here's my x's there. But where's the middle? Where's this idea of the middle of my stuff is 5. So absolute value of x minus 5, and these things were greater than 2 away. So the distance from there is greater than 2. That's what we're talking about, or that's the inequality that's being modeled there. So we'll get to these inequalities, and we'll figure out how do we solve these inequalities, just like we solved those quadratics. Okay? So first things first, back here to the equal sign. 3x plus 2 equals 17. Okay? Well, if 3x plus 2 equals 17, if its absolute value equals 17, that means that, hey, this stuff in here could be 17. Or that stuff in there could be the opposite of 17. The stuff in the absolute value could be 17, or it could be negative 17, and we solve. So 3x, we subtract 2 from both sides, could be 15, divided by 3, and x is 5. Don't make the mistake of trying to be done now and call this negative 5 over here, because it's not. It's very similar. This 3x, I'm going to subtract 2, but when I subtract 2 from negative 17, we get negative 19. And x could be negative 19 thirds. That's not reducible. So there we go. There's my answers. You should check to make sure they work. 15 plus 2 is 17. Negative 19 thirds times 3 is negative 19, plus 2 is negative 17. Its absolute value is 17. Okay? So, we have that part taken care of for equal signs. Okay? I have some other ones, like for instance, we'll come back over here. Try to leave that up there for a little bit. We'll solve a couple more. Like, what if I told you that 8 minus the absolute value of 3x equals 5? Okay? Well, here the absolute value is not solved for, so that's one of the first things I want to do is get this by itself. So if I subtract 8 from both sides, as most students do, remember that's still the opposite of 3x equals negative 3. That's a good thing, because you know this is always going to be positive. So if I were to say that this is positive and that's negative, if this came out to be a positive, we're not going to get a solution. You might work it out, but it won't work when you check it. So I divide both sides by negative 1, and I get the absolute value of 3x equals positive 3. And now we're saying, you know what? That means that 3x, the stuff in there could be 3, or the stuff in there could be negative 3. Let's check this out. This happens when x is 1. This happens when x is negative 1. And go back and check that out, you know, check those answers. What is 8 minus 3? Does it equal 5? And the answer is, the absolute value, yeah, that does. How about 8 minus the absolute value of negative 3? Does it equal 5? Yeah, that's 8 minus 3, that's 5, check. They both work. There's my answers, 2 answers. Okay? The next one is kind of a tricky example, and I say that because this is still an equal to, all right? However, this one they might say that, oh yeah, the absolute value of x minus 2 equals the absolute value of something else, and it doesn't really matter what we have here, 2x plus 1. Okay? So they're calling two absolute values equal to each other. Well, if we think about that, the stuff in the red thing could be positive, and the stuff for the blue thing could be positive, and they're both positive, so they're equal to each other. Good. But if the stuff in the inside of here were negative, and the stuff in there turned out to be negative, they're still equal. They're the same, you're saying. So basically we have two cases. Either this red stuff and the blue stuff agree. They were both positive or they were both negative, hence they're equal to each other. Or this stuff was positive and that's negative. Or this is negative and that's positive. In either case, doesn't matter because we have that negative sign somewhere. This could equal the opposite of 2x plus 1. So what you see is we still have two cases here. Either they were both the same, the red was equal to the blue, or they were opposite. One was positive, one was negative, and I can just put the opposite sign here, or I can put the opposite sign here, but I don't put it both places because then they're both the same. And you know, if you want, you could solve all four cases. You'll figure out there's only really two. They're the same or they're opposite. So when we solve this one, we subtract an x from both sides, we subtract a 1 from both sides, and we're left with x equals negative 3. Negative 2 minus 1 is negative 3. Here, we need to distribute. We get negative 2x and minus 1. So we add a 2x to both sides. We add a 2 to both sides. And x plus 2x is 3x. And negative 1 plus 2 is 1. We say x is a third. So then we go back and check. And we say, how about when it's negative 3? Is negative 3 minus 2, its absolute value, equal to 2 times negative 3 plus 1, its absolute value? That's negative 5. That's 5. That's negative 6 plus 1 is negative 5. Its absolute value is 5. And check, they're the same. Wow! We do the same thing for a third. And that's going to be 1/3 minus 6 half. No, 6/3. No, 4 halves. Its absolute value. So that's negative. Is that what I want here? How did I get a 1/2? This is a 1/3. I'm going, there's something wrong here. Yep, that's why this was supposed to be 6/3. That's a negative 5/3. Its absolute value, which is 5/3. I put a 1/3 in over here, and I get 2 times a third plus 1, its absolute value. That's 2/3 plus 3/3. That's 5/3. Check. Notice I did all that checking to make sure. There's one answer. Here's the other answer. We have two answers there. Okay? So that's the great part. Now the next part here is we want to try to go ahead. We have to use that and say, what if this was an inequality? And how do we solve an inequality? And basically, we go back to how we just solved those, and we say, I better make this good because I only have time for probably one example here. The absolute value of x minus 3, let's say it's greater than or equal to 5. Well, we forget that this is equal, and let's find the key numbers. I mean, we forget that it's greater than. We call it equal, and let's find the key numbers. So my key numbers, when it's equal, is when is x minus 3, its absolute value, equal 5. Well, that's when x minus 3 is 5, or when x minus 3 is negative 5. That's when x is 8, or x is negative 2. Why is that important? Because then I go down here and I say there's negative 2, there's 8. That's the part where it's equal. And then I just check. Check 10, check 1, check negative 4. At negative 4 minus 3, its absolute value, is it greater than or equal to 5? Yeah, 7's bigger than or equal to 5. Yes. Check 1. Is 1 minus 3, its absolute value, greater than or equal to 5? And that's 2. No. Check 10. Again, the absolute value of 7, is it greater than 5? And the answer is yes. So my answers are this region and that region. And so these answers are when x is greater than or equal to 8, or when x is less than or equal to negative 2. Don't put an and here. Don't try to make it one statement. There's two parts to this solution, so there has to be two statements. It's either here or it's there. If you try to make that one statement, it'll be incorrect. Okay? But the other possibility, and remember, you could think of this as a distance problem as well. What about the absolute value of 2x plus 1? What if that's less than? What's a good number here? 5? That means that, remember, 2x plus 1 could equal 5, or 2x plus 1 could equal negative 5. Okay? So key numbers, we're looking for key numbers when it's equal. 2x is 4, x is 2. 2x is negative 6, x is negative 3. There's negative 3, there's 2. Check negative 5, check 0, check 3. Let's see, I like checking zeros. 1 is less than 5? Yes. Negative 10 plus 1, its absolute value is less than 5. Negative 9 is less than 5. No. And then check 3, 7, no. So my solutions here are there, one region. The x's are between negative 3 and 2. Okay? I got to get done here, so hopefully that gives you a chance to get those done. Good luck. And this should be under the time limit. We're good there. So that one, because it only had one solution, we trap it in between. Put the x's between negative 3 and 2. Make them both less than signs. And that should be our solutions for that inequality. So that's, first of all, solving equalities for absolute values. And then you apply that to do the regions and check the regions like we did for the quadratics. Figure the key numbers and then check the regions. Good luck on your work.